Welcome in Dark Core. In 2024, Earth briefly had a second companion, a tiny asteroid called 2024 PT5, nicknamed a mini-moon. It didn't stay long, but it raised big questions about science, space, and the future of asteroid mining. In this video, we'll explore what made it special, why mini-moons matter, the challenges ahead, and what they could mean for future exploration. What happened, Earth's mini-moon? The story began in August 2024 when astronomers using the Atlas telescope in South Africa spotted a small object moving through the inner solar system, classified as 2024 PT5. It was later confirmed to have been temporarily captured by Earth's gravity. From late September until late November, it circled our planet before slipping back into solar orbit. At about 5 m across, it was no giant. Yet, events like this are rare enough to draw attention. Most temporary captures last only weeks or months before the object escapes again. It was one of the few documented examples in recent years, giving scientists a chance to study such a visitor up close. Its composition raised even more questions. Spectral data suggested it didn't resemble a typical asteroid. Instead, it appeared similar to lunar rock, raising the possibility it was actually a fragment blasted off the moon in an ancient impact. If true, Earth may occasionally recapture pieces of its own natural satellite, delivering ready-made lunar samples for study. But beyond the science, it sparked conversations about something more ambitious: resource use. These are known to contain valuable metals. NASA has estimated that the wealth locked in them could reach trillions of dollars in total value. Even a small body might hold significant amounts of iron, nickel, or platinum group elements. While PT5 itself was too small to be a treasure chest, its brief capture highlighted a scenario that mining advocates have long imagined. One day, Earth might temporarily snag a resource-rich asteroid close enough to reach with modest spacecraft. That possibility made it more than just a curiosity. It became a real-world case study for how future missions, scientific or industrial, might interact with temporary Earth companions. Why mini-moons matter? The importance of mini-moons lies in accessibility and scientific value. From a research perspective, each captured object offers a unique chance to study solar system materials. If PT5 was indeed lunar ejecta, then mini-moons might occasionally bring pieces of the moon itself within easy reach. Even if not, they still carry information about the composition and dynamics of near-Earth asteroids. For planetary science, every such capture is a rare opportunity. From a practical perspective, accessibility is the difference maker. Missions to distant asteroids have already been carried out. Japan's Hayabusa 2 and NASA's OSIRIS-REx successfully returned samples, but those projects cost hundreds of millions of dollars and took nearly a decade to complete, returning only small amounts of material. For mining on a commercial scale, the cost structure is impossible to sustain. Mini-moons like it change the equation. By definition, they are already in Earth's neighborhood, requiring less fuel and shorter mission times to reach. Engineers argue that capturing one and placing it into a stable orbit could create a controlled environment for testing mining techniques. This could include robotic extraction, containment systems, or even non-contact methods like using concentrated sunlight to break down material. Still, the idea should be kept in perspective. Most mini-moons are very small, often just a few meters across, and would never yield significant amounts of valuable metals. PT5 itself would have been far from profitable to mine. The real value lies in the opportunity to experiment and gain experience. If humanity is serious about someday tapping into larger asteroids, mini-moons could serve as the practice grounds to get there. It caught the eye of scientists and entrepreneurs alike, a reminder that mini-moons aren't gold mines yet, but perfect test cases bridging vision and reality. Challenges and the road ahead. Despite the excitement, turning mini-moons into usable resources is not straightforward. The technical challenges alone are considerable. Asteroids are small and irregular with almost no gravity. Landing on one isn't like touching down on a planet, it's more like trying to dock with a spinning rock in microgravity. Many rotate rapidly, making anchoring or stabilizing a spacecraft difficult. Without gravity to hold equipment in place, even simple operations become complex. Environmental conditions make things harder. Asteroids lack atmospheres, so they are exposed to radiation, extreme temperatures, and constant micro-impacts. Dust kicked up by even small disturbances can interfere with instruments. These realities mean any mining system has to be robust and adaptable in ways not yet demonstrated at scale. There are also risks to Earth. Capturing and stabilizing an object in orbit has to be done with absolute precision. A mistake could send a mini-moon onto a collision path, turning a resource into a hazard. Economics presents another challenge. Even if extraction becomes technically feasible, delivering large quantities of metals back to Earth could destabilize markets. For example, a sudden influx of platinum could collapse prices, undermining profitability. Some suggest space resources may ultimately be more valuable if used in space for constructing habitats or fueling missions rather than bringing them down to Earth. Finally, there is the legal dimension. International space law, based on treaties like the 1967 Outer Space Treaty, does not clearly define property rights over extracted materials. While some nations, including the US and Luxembourg, have created laws giving companies ownership of what they collect, there is no global framework. Without clear rules, large-scale investment is risky. Mini-moons aren't gold mines, they're stepping stones, training grounds for the bigger missions ahead. And with new observatories coming online, we'll soon spot many more. Outro. Earth's mini-moon PT-5 wasn't a gold mine, but a reminder that the future of exploration sometimes drifts right above us. The question is, will we be ready next time? Don't forget to like, share, and subscribe for more space discoveries. Thanks for watching Dark Core.